Great, everyone has a seat. Welcome to this talk. I want to start with a picture. Do you remember this machine here? Who remembers it? Yeah, some of you, great. It was the hero of my childhood. It was a good old Commodore 64. It was released in 1982, and it really shows that I'm growing old nowadays. It had about 1 megahertz, and it had 64 Ks of RAM, which is nothing compared to nowadays capacities. Sorry? I shall stay here? Okay, behind the podium. Okay? Let's do it. Cool. 64 Ks of memory, which is nothing compared to nowadays capacities. And the floppy disk stored 170 Ks, which is also not much. And perhaps someone of you know there has been even a dual-core version, a version with 2 CPU cores. It looked like this. And of course, the big challenge back then has been about resources. You thought twice before you used an integer. Perhaps a tiny integer was enough for something like this. Resources is not a big challenge anymore. Nowadays, we have different challenges. For instance, complexity. Business software is getting more and more complex, and so somehow we have to deal with this complexity. Also, we need to coordinate several teams. It is difficult enough to coordinate the members of one team, but now we have to coordinate several teams. And nowadays we have to plan for long-time maintainability. A typical software in the area of enterprise applications has to last for 10 or 20 years. And that means we have to do a proper software design, a proper architecture, as well as we have to choose carefully our technologies. And then, of course, there is this issue with milk products. Perhaps you've heard about this issue with milk products. There are milk products out there lasting longer than some JavaScript framework. Every day we get a new framework, and every day some framework is abandoned. Last time I heard someone say to another person, what you are using here is that much 2015. So let's just do the math. 2015, it has been 4 years, and some dude is finger pointing to you because you are using something that was widely used back then. So something is wrong here. And in this talk, I will present a remedy for this, a remedy that deals with web components on the one side and with micro frontends, micro apps on the other side. I will show you a demonstration that will give you an idea of how to combine those two things to create a sustainable architecture. And I will show you how to choose the proper solutions for your very own projects. But let me introduce myself. I am Manfred. I am a trainer and consultant for Angular. I am helping a lot of companies doing Angular nowadays. I am part of the Google Developer Expert team, and I'm also part of the Angular team since the beginning of this year. I'm an external member, and I'm helping them to implement new features. I'm doing a lot of stuff in the German-speaking area, but also sometimes in other parts of Europe. My current product is also about Angular. It's a workshop that deals with advanced topics you need when you try to use Angular for enterprise-scale applications. It contains a lot of stuff that are not part of the manual, because normally if you have to use Angular for the enterprise, you have to combine Angular with other things, with other ideas, with other technologies. This workshop takes part as a public workshop in some cities and more often as a private one. But now let's get started with the first part of this presentation. Let's get started with web components. So to put it in a nutshell, a web component is nothing less than a framework-independent component. You can write it with one framework and use it with other frameworks. For instance, you could write it with Angular or Vanilla.js and use it with Vue, with React, and so on. But to be honest, there is not something like a web component, at least not officially, because web component is just the umbrella term, a term that can mean different things. And the standards behind it have different names. What you see here is the current logos of those standards. For instance, when talking about web components, you have this template standard. A template is just a bunch of HTML with some placeholders in there. I think you know something like this from all the web frameworks out there. Angular has it, React has it somehow, Vue has it, so I think this is nothing new. You have HTML imports. An HTML import is just a way to import something from another HTML file. For instance, a web component. There is custom elements. It's the most vital standard here. Custom elements allows you to implement an element for your browser, a custom HTML element. And this element will be rendered by the browser, and it behaves like a traditional one, like a table, like a div, like an image, and so on and so forth. And then there is Shadow DOM. If you want to sound very mighty, you have to use the German translation, which would be Schattendom. It really sounds mighty. And this Schattendom allows you to isolate your component in terms of styling. I'm sure you know this situation where you have two style sheets, and both of them work perfectly, but when you try to use them together, all hell breaks loose. And this is exactly prevented by Shadow DOM. It isolates your component. It makes sure that your CSS file is only affecting this very one component here. So if you don't like to remember all this stuff, I do neither, then I have a good message for you. You can immediately forget about HTML imports because browser vendors agreed upon not implementing them. They said, hey, we already have something like this. We already have something like imports, namely ECMAScript imports, so let's just use them. And so what we will do is we will bundle our web components into ECMAScript bundles, into JavaScript bundles, and then we can load them perhaps statically or just dynamically on demand. The first thing I'm getting answered when I'm presenting this is, does this even work with all the browsers we still have to support? And I think we all know about which browser I'm talking about. I'm talking about IE. Who of you has to support IE? Yeah, some of you. Okay. It's getting better and better nowadays. I think it's because of the new Edge browser, which bases upon Chromium. But in the past, that was really a pain point. And the good message here is, even if you have to support this older browser, you can use it because there are polyfills. Of course, polyfills are not perfect, but you can arrange yourself with those polyfills, and so you can even support those browsers somehow. But please start testing early. Don't just start testing one day before you release. I think that will not work that well. So if you look at the browser APIs, you see that using a custom element is not difficult at all. It is just a matter of providing a class which is subclassing HTML element or some other base class provided for these purposes. In this case, I'm just going with HTML element. In addition, you have to provide a constructor. You can do this with pure ECMAScript 6 code, which means ECMAScript 2015 and above. And this constructor can attach a shadow DOM. And within this shadow DOM, you can place your own elements like a div with Hello World, because it's such a nice habit. You can even place more meaningful things in there, like a data grid or a date timetable. It just depends upon what you want to provide. Of course, in addition to this, you will also hook up some event listeners or sometimes detach those event listeners, and sometimes you will update your template. But if you want to put it in a nutshell, it is this at the end of the day. And in addition to this, you have to register this class with your browser. For this, you can go with this browser API here, custom elements define. It's baked into your browser. It gets the name of your custom element, and it gets your implementation. And after this, you can just import the bundle with your code and use this new element. This new element will be rendered by the browser, and because the browser knows it, you can use it together with all the frameworks out there. You can even use it with vanilla JS. The good message here is that most of the time you don't need to deal with these low-level browser APIs. Most of the time you can leverage your favorite framework. For instance, in Angular, we have something like Angular Elements. It is a very thin layer that allows you to wrap your existing Angular components and to expose them in terms of web components. There is Vue and the Vue CLI. This CLI allows you to export your Vue components as web components during the build. And if it comes to React, you can wrap everything by hand. Just use the code I've shown you before. And instead of directly writing something to your web component, just bootstrap a React component in there. There are also community solutions for this. So as you have seen here, web components allow you for a sustainable development. You can develop something now and reuse it all the time with all the available frameworks out there. Let's also talk about micro frontends. Nowadays, we have systems that are quite big. And a big system is very difficult to maintain. I think you know this situation. You change something on the left side and you break something on the right side. And of course, this is something you want to prevent. It is especially difficult to maintain such a big system if there are several teams involved, because those teams have to communicate with each other. Communicate. No, just kidding. Nothing against good communication. But if you are blocked all the time because you have to communicate with all the other 20 teams, something goes wrong. When you have a big system, you normally just have one leading framework and one overall architecture. Of course, you can try to squeeze in several frameworks, you can try to squeeze in several architectural styles, but at the end of the day, you will end up with a Frankenstein monster. I think you all know this Frankenstein monster, this monster that was assembled of different body parts of different people. It does not feel that well. And this one-size-fits-all situation is not good when it comes to long-time maintainability, because no one can predict the future. No one knows what happens in 5 or 10 years. Perhaps in 5 or 10 years we have better technologies, better architectural styles that fit more for the use cases we want to implement them. And in those situations, we don't want to stick with our decisions we've made 10 years ago, namely nowadays. At the end of the day, we also get a system that is very difficult to change. Changing the overall framework, changing the overall architecture is very difficult in there. But there is a solution for this, and I guess you all know this solution. The idea has been around for about 20 years, and since, let's say, about 5 years, give or take, a lot of people have rediscovered this idea and they are calling it microservices. Microservices is just a way to put your big system into tiny, hopefully isolated services, services that do not need to know much about each other. If you put this idea into the world of the front end, you will end up with micro front ends or micro apps. A lot of tiny UIs that don't need to know much about each other. And of course, this brings a lot of advantages. For instance, one advantage is you can have a separate deployment. You don't need to wait until the other teams have done. Just deploy it when you have done. And so you can provide new business value immediately. It allows you to mix and match technologies, not because you want to, but because you have to. You cannot predict the future. You do not know what you have in 10 years. You need less coordination between the teams, and you have less complexity within your micro front-end. But you have also some disadvantages. For instance, you have to deal with distributed data because you have tiny isolated applications. They should have their own databases too. You have to deal with overall distributed system, and you have to deal with UI composition. UI composition means that you have to present your overall systems or your 20 micro frontends as a common thing to your users. You are happy about having 20 tiny systems. Your user is normally not. Your user is not amused when they have to start 20 applications each and every morning. So you have to deal with this situation somehow. And as the name implies, UI composition is something you have to solve within the UI layer. Everything else can be solved in the backend, which doesn't help you much if you are both a backend and a front-end engineer. But if you are just a front-end engineer, then first and foremost, you have to compensate this issue regarding UI composition. And for this, we have several approaches. For instance, you could go with a deployment monolith. That means you have a lot of tiny client fragments that are developed independently. But when it comes to shipping them, you collect them, you put them into an overall system, you compile everything, and then you deploy everything together. This would be one strategy of dealing with micro frontends. So there are several advantages and disadvantages as always. One advantage is this is very easy, because this is exactly how current single-page application frameworks are supposed to work. They are supposed to provide a single-page application. That's why they are called single-page application frameworks. You get an optimized bundle. That means you can statically analyze your contents of your bundle and throw out everything you don't need. You get a consistent bundle because hopefully you are using the same widgets in there. You are not hopefully mixing and matching widgets and widgets library within your big monolith. When we look at the downsides, we don't get a separate deployment. We have to deploy everything at once because it is just one monolith, of course. Mixing technologies is difficult here. Of course, you can try it, but you will end up with a Frankenstein monster. And this is not a real micro front-end architecture. Another solution that fits better into the world of microservices and micro frontends is leveraging hyperlinks. That means you are ending up with several tiny single-page applications, and those tiny single-page applications are interconnected by using hyperlinks. And it seems like that hyperlinks are a major technology. They are around for 30 years, and to be honest, I have never ever heard a bad word about hyperlinks, so they really seem to work. And even though it sounds funny, there are some situations where hyperlinks are the best solution. Just think about a product suite like the Google Suite itself. It consists of several different applications, for instance, of Google Maps. Google Maps is specialized into one set of use cases, namely into working with maps and routes. And if you want to navigate to another part of the Google Suite, just follow a hyperlink on the right side. And then you get another single-page application like Google Docs or Google Forms or Google Sheets. By the way, the most important aspect of the whole presentation can be seen on this slide here. It is really vital. If you forget everything, please always remember this one aspect, namely there is a little village called Steierberg. It has my name into it. I'm very proud of this. I'm putting a lot of emphasis into this. It is part of Germany. Is someone here from Germany? Okay. Perhaps, oh yeah, I love you guys. Thank you. And if there are Germans behind the camera, I really, really love you. Okay, so let's go on with the boring technical stuff. This solution is simple because one more time we are using a single page application framework as it was intended to. But there are also some drawbacks. For instance, we will lose state. When we move over to another single page application, the first one is unloaded, and this means we will lose our application state. Also, we have to load a new application. And this is exactly what we wanted to prevent when we invented single page applications. And we need to make sure to get a consistent look and feel. Not all those single page applications should look different. When it comes to consistent look and feel, for instance, we might want that this widget here is displayed in the same manner in all our applications. And this is where the circle closes for the first time. This is where we can leverage web components because they work with a huge amount of frameworks, and so we can share them across all our applications. Another strategy for implementing micro frontends is composing several micro frontends on the server side, which means you have a lot of tiny applications, and on the server side you are just composing them together, for instance with something like server-side includes, or traditional includes you have in a lot of frameworks like PHP, Java server faces, and so on. When it comes to this solution, we have a solution that works well for traditional web applications. Web applications traditionally rendered on server side, like Java server faces or PHP or ASP.NET. And you get an optimized payload because you just have to transfer a big HTML containing everything the user wants to see. But on the other side, this does not fit that well to single-page applications because a single-page application is normally executed on the client side. If we just keep server-side rendering away, it is executed on the client side after it landed there. And so we need something better here. Another approach would be to provide a shell. A shell for me is just a single-page application that is capable of loading other single-page applications on demand. What do you think? How can we provide a single-page application that loads other single-page applications on demand? Who has an idea? Did anyone say iframe? Oh, iframe, yeah. So I don't know about you, but I'm always getting this strange feeling in the stomach if someone says iframe. But to be honest, iframes are not that bad at all. Of course, we all know there are disadvantages, but there is one big advantage, namely isolation. If you have to integrate applications from different vendors, the isolation makes sure that one application cannot harm another application within another iframe. It cannot hack the other application. It cannot influence the styles over there. You can also integrate legacy applications like, let's say, Java server faces or struts or something like this. If you don't want to use iframes, there is a better strategy here. You can bootstrap several single-page applications within one page. That means you have one index HTML, and within there you are bootstrapping your Angular application, your Angular JS application, your Vanilla JS application, your React application, and so on and so forth. And when it comes to this, the circle closes one more time because it might be a good idea to isolate your micro frontends by using web components in here. You don't have to do it, but if you do it, you have several advantages. You have a unified API for the shell. The shell does not know how to talk with your micro frontends because the shell knows, oh, this micro frontend is just a web component that behaves like a traditional element, like a table, like a div, like an image. You can mix and match, or let's say nest your micro frontends. That means you can have a Vue component with an Angular component, with an React component inside, and you have Shadow DOM, which isolates the styles. Normally, you don't want that one micro frontend is affecting the styling of the other micro frontend. If you don't want to use web components here, then I would recommend to at least use Shadow DOM. You can use Shadow DOM without the other standards for web components, just to isolate your component. So when it comes to this shell architecture, then you should keep in mind that there are two layers of architecture. The first layer is what I'm calling the macro architecture. The macro architecture is what holds your micro front ends together. It is somehow the glue between your micro front ends. And then there is the layer with the shared widgets. I'm calling this layer also the micro architecture. It is about sharing widgets. And the nice thing here is you can use the same strategies for both, but you can also use completely different strategies. For instance, you could use an iframe for the macro architecture and web components for the micro architecture. Or you could use Shadow DOM for the macro architecture and just vanilla JS code for the micro architecture. And if everything is Angular, you can just use Angular components here to share your widgets. So let me show you a simple demonstration for this. What we have here is a simple shell, and this shell is built with Angular. You can tell it by looking at the icon. And when I'm clicking here or there, I'm getting a different application loaded here. That means the JavaScript bundles are downloaded, and then the application is bootstrapped within the working area. When I'm clicking here, I'm getting another Angular application. I'm calling it my red client. And here I'm getting a Vue application that shows that we can even mix and match different technologies. And one more time, not because we want to have a zoo of single-page application frameworks, but because it might come in handy in long term. Here I have even an Angular JS application, which shows that using micro frontends can also be a strategy to migrate away from a legacy technology to something new. What we see here is the macro architecture that holds everything together. In addition to this, we also have a micro architecture, which is here about sharing widgets. And because I'm just using web components on both levels, I can mix and match everything. So as you see, within my Angular application, I'm using a Vue component, a vanilla JS component, and a component from my blue Angular client. Of course, mixing and sharing widgets is not perfect. You should avoid this, because at the end of the day and in theory, a microservice architecture as well as a micro front-end architecture is a shared nothing architecture. If you share something, you have a lot of contracts, and contracts are hard to maintain because you are not allowed to break them in a non-backwards compatible way. That's why those architectural styles are shared nothing architectures. But, you know, in practice, sometimes you have to share something to provide a common look and feel or to prevent a duplication of code, and so it might come in handy to do this. Okay. Now you have seen several solutions. We've talked about using a deployment monolith. We've talked about using hyperlinks. we've talked about server-side composition, and we've talked about this shell here, where I have shown you an example for. And now the big question is, which solution fits best for our needs? And this question is very difficult to answer, because it really depends upon your architectural styles, and because all of those approaches have some disadvantages. And to be honest, every one of us just wants to have the advantages of all of them, but none of their disadvantages. And that's why a lot of my customers are ending up in cycles when we discuss about this. And there was this day after a customer workshop where I have been very frustrated, because we are just one more time ended up in a discussion cycle. And so I went to the huddle and I thought about how can I cut this discussion short. And this was where I came up with a decision tree that shows you a first good architectural candidate for your needs. Of course, it cannot be the last word on this, but it proved to be handy in several situations. The first question I would ask you here is, do you have a lot of shared state? Shared state beyond some IDs like a customer ID or a user ID, a lot of shared state. And do you have a lot of navigation between your applications? And if you say no, then it is very likely that you have something like a product suite, like Office 365, like the Google suite, and then just start with hyperlinks. The good thing about this is, when you start with hyperlinks, you can even though switch to a more complicated approach afterwards. If you say, hey, there is a lot of state in there and the user is navigating back and forth all the time, then the next question is, do you have to integrate legacy applications, or do you need a very, 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 very strong isolation? I have this customer that builds an ERP system for a niche. It is a very special niche, and because it's a niche, they cannot implement all the parts of the application. And so they are using third-party vendor software. Some modules are from other vendors, but they want to integrate everything nicely into one common thing. And because they cannot control the other vendors, they just put this stuff into an iframe, because this is the safest way of doing this. If you say no, you don't have to respect legacy. I mean, who of us has legacy? No one has legacy, don't we? And if you don't need a strong isolation, then the next question is, do you need a separate deployment or a mix of technologies? And when you say yes, I need a separate deployment or a mix of technologies, then go with web components, or at least bootstrap different applications. Those applications can consist of web components, as shown before, or they can just be ordinary Angular, Vue, React applications. Regardless of this, always use Shadow DOM to isolate your styles. If you say, no, this is nothing that I need, because we have one product and we are done after 3 years and then we are in maintenance mode, then just provide a monolith. Just provide a monolith. You can substructure the monolith with different libraries or with a mono-repo architecture. Of course, now I'm a very nosy person. When you look at this decision tree, when you think about your current application, about your current project, who thinks that using hyperlinks is the best approach here? Okay, one person. Who thinks that using iframes is the best approach here? I'm not looking, I'm promising, I'm not looking. Who thinks? Okay. Who thinks that using web components or even bootstrapping several applications is the best approach here? Okay, some of you. And who thinks that the monolith is the best approach? Okay. And who did not raise the hand? Because you are afraid of me, or okay, fine. Who was right? Last time someone said, hey, I was right. No, everyone is right, because it really depends upon your current needs, upon your architectural goals. But it also shows you have to know your architectural goals. So if you like this talk, there is a lot more about this. When you look into my blog, you find a lot of articles, because this is currently my main topic. And even if you say, hey, I did not like this talk at all, this was a very bad talk, look into my blog. Perhaps I'm writing better than I'm speaking, who knows? So let me sum up. We have seen we can use web components to decouple ourselves from a current framework. And we have seen we can use micro frontends to decouple several themes or several projects. If you use both together, something beautiful will happen, I guarantee you. And at the end of the day, you have to evaluate. You have to know all your architectural goals. You have to know what's important and what's not important. And you have to carefully evaluate everything against them. And perhaps my decision tree might help here. Here you have my contact data. If you have any question, feel free to reach out to me. And I have also already placed my slides and my example within my blog. You can download it here. So thanks for coming and have a nice day. Yeah. Yeah, it would be fully possible to use React here. When you look at this example here, where I'm handcrafting a web component and writing a div with perhaps hello world into the web component, instead of writing those divs in there, you could bootstrap a React component, and so you would get all the benefits like Shadow DOM and so on. So that would be totally possible here. Do you have other questions?
Thank you. Assuming we have this situation with a shell component around handling the different microservices in it, and I have the situation where I have to share the state, as we said, would the shell component be the best place where to put this shared state?
Yeah, good question. How can we share state? And the first answer is try to avoid this, because a micro frontend architecture is a shared nothing architecture. At least this is the theory. But in the practice, sometimes we have to share state, and there are several approaches for this. The best approach, if you ask me, and if it fits, is using the URL. Just put the parameter into the URL, and other micro apps can fetch this parameter. They can also observe the URL and fetch all the parameters when it changes. This is the best approach, because it works like the web is intended to work, and also you can do deep linking. You can bookmark your link and load the same state sometimes after it. It also works perfectly with the back button. There are also other approaches. For instance, when you are going with just hyperlink integration, you can use the server. You can use something like WebSockets to communicate between your apps. And if you are using web components, you could also just raise an event, a custom JavaScript event, to communicate with the other parts of the applications. In all those cases, I would recommend do not demand on it. Communication can increase the usability, but if it does not work because your application is started in standalone mode, your application should not demand it. This would be the goal or the way for the best user experience.
Thank you.
Welcome.
Anything else?
Are there other questions? Okay, great. So thank you.